Hello friends, in today's video, we are going to explore remaining part of theory, event handling. Okay, event handling theory. Last part we are going to see. We will see the example of key event. So we are creating a simple key class which extends frame implements the key listener. Here we are creating message and key state. Method key, simple key is generated. Public simple key, which is a constructor, default constructor. Here we are adding key listener and adding window listener. This is provided because this is a key listener, so we can directly provide this over here as an object. Then handle key press, public void key press, key event, key state is equal to key down, repeat. Okay, so we are overriding all the provided methods by the interface key listener. So on key press, this object is passed over here, and then key state is updated as key down and repaint, call the paint method. Key release, key state key up, repaint, call the key paint method. Key type message plus is equal to key dot get key character. Okay, if the character is present, it will be displayed or appended at the end, and paint method will be called. And in the actual paint method, we are drawing string message on x and y coordinate 20 and 100, and draw string at key state 20, 50. Okay, so key state is a key down string, so it will be displayed as a message on coordinate 20 and 50. Then we are creating object of class simple key appwin new simple key appwin dot set size new dimension 200 into 150. Appwin dot set title simple key appwin dot set visible is equal to true. Okay, so our dimensions of outer window are 200, 150. Then appwin dot set visible is equal to true. So setting visibility and calling. This is the adapter which extends window adapter, and on window closing overridden method we are calling system.exit 0. So output is shown here, simple key down. This is a test. So this is the title we have provided. This is a minimize, maximize, close button. Key down event is generated, and this is the test is displayed over here. Okay. So this is the test. Whatever I am typing, its characters are appended. So we can type anything that will be displayed as a message, because message is created like message is equal to message plus key dot get key character. Okay. So whatever you will type in will be displayed as an output over here, and key down will be displayed no matter what you are doing. Okay. If you want to handle the special type of key such as arrow or function key, you need to respond them within the key pressed handler. Okay, so they are not available through key type method. Key type will be having the character generating keys. So for the arrow keys and function keys, what you have to do is you have to call the key pressed handler. To identify the key, you use their virtual key code we have already given, like vk underscore alt vk underscore etc etc. For example, next program we will see the name of the special keys we will display over here. Key event demo extends frame implements key listener. Message and key state two strings are generated. Add key listener this, add window listener, new my window adapter. Okay. So why window listener we are providing over here? Because in GUI based programs, window will not be closed by itself when you are pressing the close button of window. So for that purpose, we have to add this window listener, and in this adapter, we are implementing the on window close method, and in that we are writing system.exit 0. For that purpose, this line is important. And since it is implementing key listener, we are adding key listener to this. Okay. Then key state key down. Then every time we are getting the key code, and for every key code in integer type, If it is F1, message will be F1. F1 will be displayed. That is the function key is pressed. VK underscore F2, F2 will be pressed. VK underscore F3, F3 is pressed. Page down, page up, left arrow, right arrow are pressed and will be appended. And then key state is equal to key up and then pen. On key type, whatever I will be writing over there will be displayed as a message, and then the repent will be called. Display keystrokes, G dot drawstring message 20 into 100, G dot drawstring key state 20 into 50. Like in the previous example only, my message, whatever I will be typing, will be displayed at coordinates 20x and 100 as a y coordinate. And key state, whatever is keys up or down, will be displayed as a message on coordinates 20 and 50. Okay. And the next thing, if if at key pressed event, if I am pressing any key on the keyboard like F1 key, F2 key, F3, page down, page up, left and right. Okay. All these keys, all these special type of keys. Note down that there are not all keys we have implemented, not all special keys. Some of the keys we have implemented, just check how they are working. Okay. For the special keys, we have to handle them on the key pressed handle. Okay. This is the demo for this line. And all constants are still available. You can write down any number of constants in this switch case as you want. Okay, this is for just the sake of understanding how the constants for special characters or special keys are used. Okay, then in this main function we are creating the object of the key events demo. Dimension of the outer window is 200 into 150. Title is key event demo. Visibility is equal to true. And my window adapter is a separate class to close the window. Extend window adapter. On window closing, this method is overridden over here. We are passing window event on a close button place. System will be exit with a 0. That is successfully window will be closed. So this is the output. Here user has entered. Click right arrow. So right arrow is displayed over here. Left arrow is displayed over here. F1, F2, and F3. Okay, this sequence is not necessary that this sequence will be always there. Okay, depending upon which keys you are pressing, depending upon that your message will be generated. Okay, so message will be appended like this. First message is blank message. Okay, so if first I am pressing the page up, if suppose, so message will be starting with page up. Then if suppose I am pressing F3, so output will be like page up plus F3 plus left arrow if suppose, and then plus F1 and then F2. Depending upon the keys or sequence of keys you are pressing, the output will be generated and displayed at the position 20 into 100. Okay, and on key down will be displayed. Okay, the procedures shown in the preceding keyboard and mouse event examples can be generalized for all types of events. Okay, even those events generated by controls. Okay, so in the upcoming chapters we will see many examples that handle other types of event, but the basic structure, they will follow the same basic structure as we have discussed in this program or in this chapter. Okay, so keyboard and mouse event examples can be generalized. So which type of flow we are going to follow? What are the steps? Those steps will be common. So there are multiple types of events, but the basic structure, generalized structure will be the same. So if you are understanding this basic structure, then it will be okay, and it will be great that you will be understanding the upcoming chapters very easily. Then adapter classes. Java provides special feature called adapter class that can simplify the creation of event handler in certain situations. Okay. So we are creating event handlers. Okay. So creation of those event handler will be easy using the adapter classes. In the previous example, we created the window adapter which extends the adapter. Okay. So these are types of adapters Those will simplify the process of event handling. Adapter class provides an empty implementation of all methods in an event listener interface. So depending upon which type of method you want to implement, you can implement only that method. These classes are useful when you want to receive and process only some of the events that are handled by a particular event listener interface. Depending upon your choice, depending upon your need, you will implement only those methods. You will override only those methods. Okay. So it is not compulsory to you to implement all the methods from the event listener interface. You can define a new class to act as an event listener by extending one of the adapter classes and implementing only those events in which you are interested. Okay. So what you will create? First of all, you will create a class like class my class that will act as the event listener, and you will extend the adapter. Extend any of the adapter classes you require, any of the classes you are interested in, and implement only those methods those you like. It is not compulsory you will implement all of those methods. For example, mouse motion adapter has two methods, mouse drag and mouse move, which are the methods defined by mouse motion listener interface. So it is up to you which method you will implement. If you are interested only in the mouse drag event, then you could simply extend mouse motion adapter and override mouse drag method. Okay. So mouse motion adapter is common. And see, when you are implementing interface, it is compulsory to you that whichever number of methods are there in the interface, you must implement them. But when you are extending the adapter class, methods are available, and depending upon your choice, you can override those methods only. Okay, so here in this example, what we have seen? If you are interested only mouse in only mouse drag, what you will do? You will extend the mouse motion adapter class and implement the mouse drag method. The implementation of mouse mode would handle the mouse motion event for you. So it is not compulsory for you. Table upcoming lists the several commonly used adapter classes in java.awt.event and notes the interface that each implemented. Okay. So you will see some commonly used adapters classes. You have already seen one adapter class in action in the preceding examples, window adapter for window closing. Recall the window listener interface defines 7 methods, but only one window closing was needed by other programs. So for that purpose, we are not implementing the window listener interface. We are extending the window adapter class. If we would have implemented the window listener interface, we would have to implement all the 7 methods provided by that interface. But since we are extending the adapter class window adapter, only one method we will be implementing, window closing. Okay, that is required. To use of the adapter prevented the need to provide empty implementations of another unused methods, thus avoiding clutter in the examples. So as simple as that. Depending upon your need, you will implement the method. As you would expect other adapter classes can be employed in a similar fashions. So now we will see the example of adapter. It uses mouse adapter to respond the mouse click and mouse drag event. In the table, mouse adapter implements all of the mouse listener interfaces. You can use it to handle all types of mouse events. Okay. So our mouse adapter implements all the mouse listener interfaces. So all types of mouse event can be handled. You need to override only those methods that are used by your program. It is your choice. In the following example, my mouse adapter extend mouse adapter and override the mouse click and mouse drag method. So depending upon your choice, you can implement as many methods as you need. All other mouse events are ignored. Notice that the mouse adapter constructor is passed a reference to the adapter demo instance. This reference is then saved and used to assign a string to message and to invoke depend on the object that receives the event notification. Okay, so my mouse adapter constructor is passed as a reference to adapter demo instance. So we will see the example in detail. So these are the commonly used listener interfaces implemented by adapter classes. Adapter class listener interface, component adapter, its interface is component listener, container adapter, container listener, focus adapter, focus listener, key adapter, key listener, mouse adapter, mouse listener, mouse motion listener, and mouse wheel listener, mouse motion adapter, mouse motion listener, window adapter, window listener, window focus listener, and window state listener. As before, a window adapter is used to handle a window closing event. Okay. So our class adapter demo extends frame. Message is created in adapter demo. In adapter demo constructor, mouse listener, new mouse adapter is provided. Add mouse motion listener, new mouse adapter, this is provided. And window listener, my window adapter is provided. Display the mouse information in the field message 20 into 80. So 20 and 80 will be the coordinates in which we will be displaying the message. Here we are creating the object of class, then size 200 into 150, that will be our window size, then title adapter demo, and visibility is equal to true. Now we will implement only mouse click and drag events on class my mouse adapter, extends mouse adapter, adapter demo, okay. My mouse adapter, adapter demo, this dot adapter demo is equal to adapter demo. Okay, so my mouse adapter we have created. Here we are passing the adapter demo object, okay, in the bracket as a parameter. To this constructor of this adapter class, we are passing the adapter demo object, and then we are initializing it to adapter demo is equal to adapter demo. Then handle mouse click event, mouse event emit. So adapter demo dot message mouse click, and its repent method will be called mouse drag. Adapter demo dot message mouse drag and repent, that is paint, will be called. And in the window adapter express window adapter, system dot exit is equal to 0. System dot exit 0. As you can see, not having to implement all of the methods defined by the mouse motion listener, mouse wheel listener, and mouse wheel listener interfaces save you considerable amount of efforts and prevents your code from becoming cluttered with empty methods. Okay, so it is not compulsory to you. Other than implementing all the methods defined by mouse motion listener, mouse listener, and mouse wheel listener, we will implement the only methods. Those methods are mouse click and mouse drag, and all others will be taken care of by adapters. You might want to try rewriting one of the keyboard input examples shown earlier so that it will be a key adapter. Okay, this can be homework for you. You can rewrite one of the keyboard input examples we have seen. So instead of implementing the key listener interface, you can extend the key adapter class. Next, inner classes. Basics of inner classes we have seen already. So here we will see why they are important. Inner class is a class defined within another class or even within an expression. Okay. So class within a class is the inner class. This section illustrates how inner class we use to simplify the code when using event adapter classes. So inner class are classes within the class. So here we will use them to simplify the code when using the event adapter class. So we will see now the benefits of inner classes. For that, we will see the example that is following that does not use an inner class. Goal is to display the string mouse press when the mouse is pressed. Similar to the approach, a reference to mouse press demo is passed to the my mouse adapter constructor and saved. Like in the previous example, we passed the object of the previous class. This reference is used to assign a string to message and invoke depend that we call to paint. Okay. So a program that does not use the inner class. Public class mouse press demo extends frame message is there. Add mouse listener my mouse adapter and window listener my window adapter. Draw string with a message. Mouse press demo object is created. Dimensions are 200, 150. Visibility true. Title is mouse press demo. So now we will create a class that extends the mouse adapter. Class my mouse adapter extends mouse adapter. Mouse press demo, mouse press demo. Public my mouse adapter mouse press demo object is passed over here, and this will be initialized like this dot mouse press demo is equal to mouse press demo. So how we will apply it, how we will append the message like mouse press demo dot message mouse press demo dot repeat. Okay, and this is the window adapter. So now we will see the example that have the inner class in that. Here inner class demo is the top level class and my mouse adapter is the inner class in that. Okay. So my mouse adapter is defined within the scope of inner class demo. It has access to all of the variables and methods within the scope of that class. Okay. So my mouse adapter is called defined in the inside the inner class demo. Scope means in the opening and closing parenthesis of inner class demo, it has access to all of the variables and methods by the scope of that class, that is inner class demo. Okay, so we have already understood the inner classes in the previous chapters. The mouse press method can call repaint method directly. No longer need to do this by stored reference. Okay, so we don't have to pass the parameter. The same applies to assigning a value to message. Thus, it is no longer necessary to pass my mouse adapter reference to a invoking object, and my window adapter has been made into another inner class. So this is the outside class inner class demo. Okay, public inner class demo. We are adding add mouse listener, new mouse adapter, and add window listener, new window adapter. Okay. Then class my mouse adapter extends mouse adapter, public void mouse press, mouse event me. Message is equal to mouse pressed. Okay. So what we are doing, inner class to handle mouse pressed events. This extends mouse adapter. On mouse pressed, we are appending the message mouse pressed. And okay, then mouse pressed is message appended, and repaint is called the paint method, and inner class to handle window close events with the system.exit 0 and g.drawString message 2018. Okay, so inner class demo object is created. Dimensions are 200, 150. Inner class demo set visibility is equal to true. Okay, so this way, using the inner class, we can directly call the repaint method that will explicitly call the paint. Okay, the mouse press method can call the repaint method directly. This is the mouse press method that call the repaint method directly. Okay. Then next, anonymous inner classes. An anonymous inner class is one that is not assigned a name. So no name inner class is there. This section we will see how an anonymous inner class can facilitate the writing of event handlers. So we will find out the program now. In the following listing, its goal is to display the string mouse pressed when the mouse is pressed. Anonymous inner class demo extends frame message anonymous inner class demo. Okay, to handle the mouse press events, add mouse listener, new mouse adapter. On mouse press, we are writing mouse press, and window listener system.exit paint method drawString. In the main method, object of anonymous inner class demo is created. Then new window is created of size 200 into 150. Then title is anonymous inner class demo. Set visibility is equal to true. There is one top level class anonymous inner class demo, and its constructor called the add mouse listener method. Okay. So constructor calls add mouse listener. Okay, add mouse listener, new mouse adapter. So inside that, we are opening and closing the bracket, and here we are providing the mouse press event. Okay, this argument is an expression that defines an instantiated anonymous inner class. So we will see this expression. New mouse adapter indicates the compiler that the code between that opening and closing braces, curly braces, defines anonymous inner class, and that class extends mouse adapters. So this new class is not named, but it is automatically instantiated after opening and closing these brackets. Okay, then this expression is executed. How we are writing this? Like new mouse adapter. So instead of writing the class name, we are directly instantiating using new mouse adapter opening and closing. This anonymous inner class you will find many times in your Java applications, worldwide real world Java applications. So you will understand it better. Okay, when more you will practice, more you will understand it. Okay. This syntax can be generalized and is the same when creating another anonymous classes such as when an anonymous inner adapter is created by the program. Okay, so this inner class is inside the scope of anonymous inner class demo. It has access to all of the variables and methods inside this class, and it can call repent method and access methods directly. Both named and anonymous inner classes solve some annoying problems in simple yet effective way. So it is since all the stuff is written inside the inner class, you can directly access all of the methods and variables. They also allow you to create more efficient code. So this way we have completed all the topics related to event handling. In the next upcoming session, we will see practical part related to this chapter. So meet you in the next session. Till you can enjoy, you can understand, learn, and remember the event handling process. This is very interesting chapter, and the upcoming chapter will be having all the other types of event other than key event and mouse event. So those will be more interesting than this. Okay, so enjoy the event handling chapter. We will meet you in the next session with the practical examples. Thank you so much.